So we've already talked about multiplying and dividing rational expressions. Let's talk about how to add and subtract them. So when I'm adding and subtracting just any old fraction, right, I need a common denominator, right? So if I had, a half plus a third, they don't have the same denominator. So what we've been taught to do is we multiply by the other denominator on the top and bottom of the other fractions, and essentially multiplying by 1, right? So not changing anything. And so, what we're going to do when we have something a little more complicated, something like this, is we're going to basically do the same thing, okay? So if I look at these two expressions, x plus 2 over x plus 3, x minus 1 or x plus 1, they don't have the same denominator. I need a new denominator, okay, that is going to have each of these as factors. So the easiest way to do that is to multiply them together. Which means I'm going to multiply by the missing factor on the top and bottom of each fraction. So for the first one, it's x plus 2 over x plus 3. We're going to multiply by x plus 1 because that's the missing factor. And something to remember here is, I always like to put everything in parentheses because it reminds me that I'm going to be foiling these out. Okay, I have to foil these out. For the other one, x minus 1, x plus 1, right? The missing factor will be x plus 3. So we're going to multiply by that on both sides. So what we end up with, I have a big long fraction, right? They both have the same denominator. Okay, I can change order when I multiply, so that's not a problem there. They have the same denominator. So I'm going to put them in the same fraction. So x plus 2 times x plus 1. So x times x, I have x squared, right? Plus 2 times x, so 2x, plus 1 times x, right? So plus x, and then plus 2 times 1, so plus 2. Okay? For the second one, same thing. So x times x, we have an x squared, minus x, plus 3x. Sorry, I'm running out of room here. And then minus 1 times 3, so minus 3. So let's clean this up a little bit. I'm going to combine some like terms. It looks like I have an x squared and another x squared. So I have 2x squared here. Oh, that's looking a little large. So I have 2x squared plus, what would this be? So I took care of my x squareds. Now I have a 2x plus 1 is 3, minus 1 back to 2, plus 3, so that should be a total of 5x. And then plus 2 minus 3, so 2 minus 3, what's that, minus 1? Right? We could try to factor the top. I don't think it's going to work. So if we wanted to take it one step further, we'll just go ahead and FOIL the bottom. And one thing you should notice is problems like these take time. They're very time consuming. There's a lot of steps, mostly involving FOIL and factoring, which is why we spend so much time on it. So let's see, x squared plus 3x, and then plus 1x, and then plus 3. So our final answer, 2x squared plus 5x minus 1. over x squared plus 4x plus 3. A lot of work just to get one answer. So if you need to pause it to copy this down, please go ahead and do that. I'm going to scroll in a little bit and I'm going to do another example. Okay, let's look at another example. So let's do something where the top of each fraction is a little bit simpler. So we just have 2 over x squared plus 3x plus 2 plus, we'll do 3 over x squared plus 5x plus 6. So in this, the numerators, the top of the fractions, are simpler, but there's something I have to do to the bottom in order to make this addition a little bit easier. So what I'm going to do when I have something like this is I'm going to factor the bottom, and I'm going to see if there are any common factors. So when I factor the bottom, so multiplies to 2, adds to 3, that's 2 and 1. So I have x plus 2, x plus 1. Plus 3 over, let's see, multiplies to 6 and adds to 5. So that will be x plus 2 and x plus 3. So they both share an x plus 2. Awesome. What that means is I just have to multiply by the missing factor in each one. So I'm going to multiply by, let's see, we need an x plus 3 in the first one. And I need an x plus 1 in the second fraction. So now all my factors match on the bottom, on my denominator. And let's go ahead, let's simplify the top, see what we get. So 2x, let's see, 2 times x, 2x, plus 3, so 2x, 2 times 3, 6. 3 times x, 3x, plus 3, distribute that 3. And we have this whole mess on the bottom. I'm going to write my factors in this order because it looks nice to me. You can do that if you'd like, or write it in any order, that's fine. So from here, we could leave these all factored out on the bottom, that's fine. We could multiply them all through, also fine. But regardless, we will combine our like terms and simplify on top here. So 2x, 3x, I got what, 5x? 6 plus 3, 9. Not factorable on top. And we're honestly just going to leave this stuff on bottom, not really bother with multiplying it all out. I could, but I don't want to waste your time. I waste enough of it as it is. So now we have a new one, so we're subtracting now, okay? So we're going to have to keep track of some negatives. And if I look at my second expression, I have one of the factors already, right? So I just need to multiply by one thing in the second expression in order to have matching factors. So I've multiplied by x plus 1 on the top and bottom. So we'll multiply by x plus 1, right? And now we have matching denominators. So the first denominator doesn't change. Second one, let's see, 5 times x. Oh, wait a second. I have a negative 5 out here. Here, let's take a step back. So I have a negative 5 that I have to remember to distribute here. Right? Something that a lot of people forget is they'll just go and distribute this 5 and they won't remember that it's negative, and that's going to screw things up. So we have to remember to distribute the negative. So minus 5x, negative 5 times 1 minus 5. let's FOIL the bottom out, because we can. So let's see, x times x, I got x squared, 1x, so plus 1x, minus 4x, and then 1 times negative 4 minus 4. Combine some like terms here. 7 minus 5, I get 2 minus 5x on top. On the bottom, x squared minus 3x minus 4. So remember, when we're adding or subtracting fractions, you've got to get a common denominator, and we do that by multiplying by the missing factor on both sides.